Hi, my name is Heather Plunkard, and I am currently a Recording Arts Bachelor student in Javier Rivera's October 2010 FOP class, section number 2. Today, we're going to be discussing the concepts of mass and density and how they can relate back to percussion mallets. So, in order to get started, let's talk about what mass and density actually are. Mass can be simply defined as how much matter an object contains. So in today's experiments, while looking at a percussion mallet, we will be specifically looking at the mass of the mallet head. And while mass and weight do have a direct correlation, they are not the same thing. To find the weight of an object, we would take that object's mass and multiply it by the gravitational constant 10 meters per second squared. For example, if this percussion mallet were to have a mass of 2 kilograms, we would take that mass and multiply it by 10 meters per second squared to get a weight of 20 newtons. Density, on the other hand, is a measure of how much mass an object occupies. When thinking about density, try thinking about an empty can. Now, if this were our object, and we were to put a few things inside of it, say a couple of mallets, you'll see that these mallets are free to move about. They're not compacted inside of the can, and they're just loosely floating around. That means that this object would have a very low density. However, if we were to start putting more objects inside of the can, maybe a bundle of mallets, you'll see that it becomes harder for them to move about. This means that there is more mass held inside the object, and therefore the object is more dense. To find the density of an object, we simply take the object's mass and divide it by the object's volume. Volume is a measurement of how much space an object takes up. And to find volume, we simply multiply the length, the width, and the height of the object together. When we divide the mass of an object by its volume, we can find its density. So, to conduct today's experiment, you're going to need a few items. I'm going to be using 2 of my homemade mallets. The first one is this wooden tip mallet. Now, while the head of this mallet may seem quite small, it is solid wood and therefore very dense. The other mallet I'm going to be using, I affectionately call my Q-tip mallet. While the head of the Q-tip mallet might seem extremely large compared to the wooden tip mallet, the Q-tip mallet is made out of yarn and therefore is less dense. Also for this experiment, I'm going to be using my empty paint can. Now, if you don't happen to have an empty paint can lying around the house, you could use an empty box or a jug, maybe even a barrel or a bucket. Anything that is empty will work. Some other household items you are going to need will be 1 toothbrush. Please do not use this toothbrush after you do the experiment. You will also be needing 1 Q-tip, an industrial hammer. Please be careful with the industrial hammer. And 1 box of spaghetti. No product placement intended. With the first part of our experiment, we will be demonstrating how the mass of an object can affect its noise production. In order to do this, we will be using the bottom of our empty paint can and the previously mentioned household items. With this experiment, we will be striking the bottom of the paint can with each of the household items, and hopefully will prove that the more massive the item, the louder noise it will produce. So, to start things out, I'm going to be using what I like to call my middle ground household item, or the toothbrush. Now, the toothbrush is not as massive as the industrial hammer, however, it is more massive than the Q-tip or the spaghetti. So we are going to start out with the base of the toothbrush, and then we will see how our extremes compare. So please stand far away when striking the paint can. And in 3, 2, 1. As you just heard, when striking the paint can with the toothbrush, a resonating sound occurs. Now this time we're going to perform the same exact movement, only we are going to use our industrial hammer. If you have any kind of safety goggles, or if you're using an older bucket or pail which may have rust on it, please use your safety goggles, use gloves, protect yourself when doing this. So, once again, in 3, 2, 1. As you just heard, a much louder sound occurs whenever we hit the can with the more massive object. And even as you can see, I have dented my bucket here. This is because the hammer is so much more massive than the pail that whenever the impact occurred, it did more damage to the poor pail than it did to the hammer. With this next step, we're going to move on to our less massive household objects, this time using the Q-tip. Now, I don't believe any safety glasses or gloves will be necessary for this take. Okay, and once again, in 3, 2, 1. Obviously, a softer sound is created when we use a less massive object, and no dents were created by our little Q-tip friend. For our final mass test, we will be using a strand of spaghetti. Once again, I don't feel that any safety goggles or gloves may be necessary for this experiment. However, you don't want to eat the spaghetti after this. Just keep that in mind. Throw away the spaghetti. Okay, and lastly, in 3, 2, 1. As you just heard, a very quiet noise is made by the strand of spaghetti. And as you can see here, upon impact, the strand of spaghetti was broken into several different pieces. Actually, there's a few of them. There's another one. This is because the strand of spaghetti has a very small mass, and once again, upon impact, while the pail this time was more massive than the spaghetti, instead of denting the pail, we splintered the spaghetti into several tiny pieces. Now we're going to move on to our density tests. And once again, in order to perform these, we're going to be using 2 of my homemade mallets. The wooden tipped mallet and the Q-tip mallet. And we're still going to be using the bottom of the same paint can as earlier. This time when we listen to the sound, we're going to be listening to the loudness of the sound and what kind of pitch it gives off. Is it a higher pitch? Is it a deeper pitch? How is the sound affected by the density of the mallets rather than their massiveness? So to begin, we're going to strike the same bottom of the pail as before, this time with our wooden mallet. 3, 2, 1. As you can hear, a very loud and almost higher pitched sound comes from the mallet. This time we're going to strike the same bottom of the pail with our Q-tip mallet, and we're going to see what difference the density has in the change of sound. In 3, 2, 1. As you can hear, the sound given off is more of a gong-like effect. Because the yarn that is covering this mallet is less dense, it actually absorbs the sound waves coming off of the pail instead of reflecting them. This causes the pitch to sound deeper, and it causes the sound itself to be much quieter. So, what did we learn in today's experiment? Well, we first found out that the more massive an object we use as a percussion mallet, the louder the sound we will receive. When using a less massive object like our friend the strand of spaghetti, not only does the mallet snap into several pieces, it also produces a much quieter tone. When instead using the industrial hammer, we not only damage the object we're striking, but we create a very loud tone which isn't necessarily useful in many applications. When looking at density within a percussion mallet, we found out that using a more dense material, like a wooden-headed mallet, will create a higher pitched and louder sound than when using a less dense and more padded mallet, such as our friend the Q-tip mallet. The Q-tip mallet will absorb the sound and will give a deeper tone. Overall, there are many things to consider when choosing a percussion mallet. If you're rocking out with some heavy hitting keys, well, maybe a hammer will work. Just be careful not to damage the instrument you're playing. If you want to create a softer, more ambient sound, I wouldn't necessarily recommend a piece of spaghetti, but maybe a toothbrush or a Q-tip mallet will work just fine. Once again, my name is Heather Plunkard, and I hope you learned a little something today about mass, density, and the physics of percussion mallets. Thanks.